is a safety relief valve. You'll note that has a spring. This spring is currently being compressed, and it's being compressed by a little compressive force on the stem that runs down. I don't know if you can see the stem. Well, here's how you can see the stem. Maybe. But there is a stem in there. Should be able to see the stem. But stem, and there's a certain amount of compression that's being placed on the spring. If I operate this lever, it will lift the valve disc that's inside this safety relief valve. Safety relief valve is used and designed to relieve pressure from some type of pressure vessel to prevent overpressurization. If you have a pressure vessel and it has too much pressure inside of it, it can explode. Well, if it explodes, that's a catastrophic failure. You can hurt people, you've damaged equipment, and so that's why you'd like to have a valve like this, similar to this, installed so that you won't overpressurize your pressure vessel and cause any type of catastrophic failure. If you note, this is the arm, and like I said, if you lift this, you will open the valve and you will blow the contents of whatever pressure vessel you have. You'll blow the contents out. We'll go into some specific details regarding the safety relief valve as well as the relief valves, and we'll note the differences between the two. If you note, it has a cap here, and the cap has a little pinion that actually attaches the handle, the safety relief valve handle, or the SRV handle, and allows it to pivot like a pinion. And so the handle actually has a lip that it comes in contact with here under this cap, and that's what actually lifts the disc, compresses the spring and lifts the disc from the pressure vessel nozzle. Here, we just talked about the pinion, or the pivot point for the handle. Now the little key that's in the pivot point has a lead seal, and what this lead seal is there for is to show that no one has gone inside this cap, because inside this cap there's a nut or a bolt that, well, not a bolt, but a nut that can be tightened or loosened. If I tighten it, then I increase the amount of compression. If I increase the amount of compression, then that raises the pressure at which this valve will operate. So I actually change the lift set point by changing the bolt position inside this cap. We'll talk about how to calculate the amount of force being placed on the disc and how much pressure will be required to lift that particular disc, and that's all based on our pressure force area relationship. Pressure equals force divided by area. Same equation we'll use to check the set points on these types of valves. Now I'm going to disassemble this valve. Note that since the spring is compressed, there is some tension on this valve. So as I start to loosen these bolts, the tension will be relieved, but there may be some popping. So I'm going to make sure I have my PPE on before I do that. Okay, as I start to loosen the bolts, okay, now it feels that the bonnet is loose now. Okay, we can actually see movement, some motion, and we'll go ahead and complete the disassembly. Well, we won't disassemble everything, but we do want to take a good look at the disc inside the safety relief valve. Okay, we have just taken all the bolts out, and we're going to lift the spring, stem, bonnet, disc. I'm going to lift it from the body. So now you see that I have a disc here. It's unlike, well, it is circular, but it's unlike the disc that was in the gate valve in that it sits down over the nozzle. I'll show you the internals of the valve body. So the flow will actually come through this hole here. So my pressurized end is down here by my body, and the disc sits inside this area. Okay, now we'll take the disc off of the stem. Now you see how the disc actually fits onto the stem. The stem runs through the springs and up into the cap where the nut is, that I can change the actual lifting pressure. That's where the disc screws into the stem, or the disc screws onto the stem. Now if you note, and let's see if I can get you. You have a center circle. See if I can use my pencil to try to show you this. You have an inner circle and an outer circle. This part actually sits onto the nozzle, and as it sits on the nozzle, it maintains the pressure inside. When the pressure inside the pressure vessel increases to the point where it actually compresses, this spring moves the stem up. When it moves the stem up, it compresses the spring more, but it opens the valve. Once it opens the valve and it lifts this seat or lifts this disc from its seat, now I've exposed not only this part to the pressure, but I've also included this part. So I've gone from this diameter to now the diameter of the full disc. From this diameter to this diameter. So I've increased about a quarter. Well, it looks like it might be close to a half an inch there. So now if I change the diameter like that, I've changed the area. And if I change the area in the pressure equals force over area equation, if I change the area, what have I done to the pressure? That's something that we're going to have to discuss in detail for a safety relief valve, because that determines how much blowdown you get on an SRV. I've reinstalled the disc onto the stem. There's a little play there. So you have to make sure that you get it flush into the nozzle area or onto the nozzle seat, the seat of the valve. And this valve actually bolts onto a flanged area on the side of your pressure vessel, or on the top of your pressure vessel. There's a flange there that will allow you to bolt this valve on that pressure vessel. Now, as I start to put the nuts or the bolts in, it will start to place more compression on the spring, and the valve will tighten up again. So as I do this, if you have any questions related to safety relief valves or relief valves, the internals of the valve that we just looked at, we'll discuss it in class. Now that I have reassembled the valve, I will take the cap off. Now, since this is just a demonstration valve, one I use for teaching, the seal is broken. Now, in the field, if you find a broken seal, then you don't know if that valve is set properly. Whenever they set the lift set point for these valves, they'll install this lead seal. And that lets the maintenance personnel know lets them know that no one has gone in that valve cap since they set the pressure. So that's why they put a seal on it. They want to make sure the valve is set properly. The federal government as well as state governments determine what lifts set pressures can be on a particular pressure vessel. ASME, there's a design, and it essentially says that the set point of a relief valve can't be set any more than plus or minus 3 of the lift set pressure. So whatever the set point is, the design set point, this valve has to be able to lift within plus or minus 1% of that set point. So that's why you have this seal in, because they have to make sure to meet the law, it has to be within plus or minus 1%. Now, as time goes on, the valve has an opportunity to drift. And so when I find a valve, if I test a valve that's in a system, it has to be within plus or minus 3% of its lift set point. And that's acceptable. But when I install it, it has to be within plus or minus 1%. Now I'm removing the handle, which is used to open the valve. And now you can start to see some of the portions inside here. I believe you can see the nut that you actually turn to change the set point. Now I have a screw here. Now I can remove the cap. Now I use that nut to actually turn. It's a couple of nuts here, and I can change the position of the stem. I can cause the stem to compress more on the spring, and if it compresses more, I've raised the set point pressure. If I loosen it so it's not as much compression, I have lowered the set point pressure. So now the valve is back in proper working order. If you have any additional questions, just hold them until we get to the discussion portion, and we'll talk about safety valves as well as relief valves.